I'm sorry, no one thought to tell the students that reserved means you, so you're welcome to seat in reserved seats. So good morning and welcome to Convocation 2025. I'm Kevin Gilmartin. I'm a professor of English in the Humanities and Social Sciences Division at Caltech, and I'm currently Vice President for Student Affairs. And I'm delighted to have the opportunity to lead this event and to join other members of our community, particularly Dean Yanner and Dean Chien, who led the procession in celebrating the opening of the academic year, and for students, the beginning of your academic journey with us. One piece of housekeeping for everyone who's seated. I've been asked before we start to look around and find your nearest fire exit. For most of you, that will be behind you. So new students, welcome. You arrive at Caltech during a singularly exciting, challenging, and transformative phase in the history of science and technology, and I also think in Caltech's contribution to that history. The theme of this year's convocation, Advancing Intelligence, Science, Ethics, and Exploration in the Age of AI, reflects this extraordinary moment that we all share, where artificial intelligence is just one of many social and technological forces that are realigning how we learn and communicate and conduct research, and compelling us to reflect very intensively on our shared academic and research enterprise. Caltech is a place where profound discoveries happen collaboratively and at disciplinary intersections, where theory engages application, and where fundamental curiosity drives meaningful and socially impactful innovation. AI involves dynamic intersections of this kind and touches everything from astrophysics and biology to philosophy and public policy and all of our daily lives. In arriving at Caltech at this time, you will have the opportunity to advance as well as witness and experience these changes. The research you'll conduct, the problems you'll confront, the social and ethical frameworks that you'll engage with will all help shape how AI develops as a distinctly human enterprise. And it will here at Caltech be just that, a very human enterprise. The path ahead as students is going to challenge you in many ways that you may not expect. But you won't navigate any of these challenges alone. You are joining a community that just welcomed you, one that values collaboration, and again, essentially human and social collaboration, as much as it does competition, and that prizes reflection and deliberation along the way, as well as highly ambitious innovation. Your fellow students, our network of support staff, and the faculty who lead the Institute's research mission are all very much invested in your success, and we're here to support you. With that in mind, in addressing AI on our campus, this faculty panel will offer a window into how we do science, engineering, and innovation here at Caltech. You'll hear from committed and collaborative faculty and researchers who are advancing new forms of intelligence in the lab, in the classroom, across our community, and beyond. Now it's my pleasure to introduce the president of Caltech, Dr. Tom Rosenbaum. As the Sonia and William Davidow Presidential Chair and Professor of Physics, President Rosenbaum brings both a profound scientific expertise in quantum materials and a compelling vision of how our extraordinary research and learning community can adapt and thrive in these rapidly changing times. His leadership has continued to position Caltech at the forefront of society's most pressing challenges, while maintaining our commitment to fundamental research and educational excellence, and placing the student experience, the experience you all are going to have here, firmly at the center of this institutional mission. Please join me in welcoming President Rosenbaum.
Thank you, Kevin, and welcome, a formal welcome to one of the great universities of the world. We're really excited. Yeah, that deserves some applause. We're really excited to have you join the close-knit, supportive Caltech community. You will come at a time when the scientific possibilities are limitless. Whether it's determining whether life exists somewhere else in our solar system, those rocks on Mars with potential biosignatures, or in planets orbiting other suns, or taking part in the second quantum revolution based on Einstein's spooky action at a distance, quantum entanglement, which will allow you to develop new quantum sensors and perhaps quantum computers. Or discerning the inner workings of the brain and developing interventions that can attack or help prevent neurological diseases. Or harnessing AI to redefine scientific disciplines, part of the panel discussion you will hear today, as well as the philosophical, ethical, and educational implications of AI. Or solving the preeminent challenge of your generation, global warming. There is no better place in the world to do research than Caltech, and I say that modestly. Whether you are an undergraduate, a graduate student, a postdoc, or a faculty member. You also come at a time when the challenges are great. The assault on science and on higher education is profound. We believe in truth, we believe in data, we believe in evidence-based reasoning. We believe in the power of science and technology to further human knowledge and to improve people's lives. Proudly be part of this Caltech mission. Hold on to your dreams and immerse yourself in learning and discovery. We will do all that we can to help guide you on this path. Congratulations at the start of your Caltech journey. I wish you the joy of discovery, inside and outside of the classroom, the development of lifelong passions and friendships, and the fulfillment of using your considerable skills to make the world a better place. Thank you.
Thank you, President Rosenbaum. So I'm now pleased to introduce our undergraduate speaker for the day, Ashlyn Royce, who's president of ASCIT, the Associated Students of the California Institute of Technology, which is our primary undergraduate student leadership organization. As a computer science and data science major, Ashlyn engages the themes of today's program in her own work, and she joins that work with a deep commitment to advocacy and community building on behalf of all students at Caltech. Her willingness to assume the responsibility of student leadership amidst a vigorous academic program reflects the collaborative spirit that makes Caltech special. And I can say from working with student leaders, I encourage all of you to take that path if it works for you while you're here. But I also want to acknowledge that our student leaders devote extraordinary time and energy to the entire community. So please join me in warmly welcoming Ashlyn.
Welcome, everyone. I'm so honored to be one of the first to welcome you to Caltech. I know that the struggles you overcame to get to this point were tremendous, and I applaud you for your tenacity. It will serve you well over the next 4 years. I remember 4 years ago stepping onto this campus and immediately beginning to think, did I make the right choice? Would I fit in with my peers? Would I be able to keep up? Note that if you're having the same questions, you are not the only one. Every single person in this room has had the exact same thoughts. Those first few moments of uncertainty gave way to something incredible. The realization that Caltech is not just about lectures and problem sets, but about celebrating the passion and curiosity that exists in us all. It is the place where even the most ridiculous ideas, like changing the Hollywood sign to say Caltech, become reality. Here, boldness and creativity are not only encouraged, but celebrated. Whatever you envision, no matter how ambitious, there are always going to be people and resources ready to support you and help you bring your ideas to life. And that's the novelty of Caltech, not just the ideas that brew here, but the spirits of those who envision them. It is an immense privilege just to exist here, to be inspired and stimulated by every person you meet and every class you take. I challenge you, be fearless in your scientific and academic pursuits. Ask the questions no one else is asking. See every failure as a badge of honor that fuels you. Every obstacle you face, every creative decision you make, strengthens the truth behind science and technology beyond the borders of this campus. Today's challenges as scientists and engineers feel more pressing than ever, but you will never be alone. The hurdles ahead will feel lighter when you lean on your fellow students. Caltech admits so few students for the best reason. Each of you have something unique that is instrumental to the future of Caltech. There is a mountain to learn from each of your fellow classmates and the rest of the upperclassmen here. I implore you to seek them out and what they have to give you. They will provide you new perspectives and enrich your life in ways you could never imagine. Your persistence and zeal has taken you far. It's taken you to where you're seated right now. But it can and it will take you further. Remember the reason why you came here, and let it power your next 4 years. With that, I'm incredibly excited to welcome you to Caltech. I cannot wait to witness what you all dream of. Thank you.
Thanks, Ashlyn. We'll now hear from Zachary Chase and Wesley Patel, who are co-chairs of the Graduate Student Council, and coincidentally, both work under the mentorship of Professor Catherine Faber, or perhaps not so coincidentally, because I will say that it's no surprise that two of our extraordinary student leaders are mentored by Kathy, who's here with us today. Zach's research involves developing new manufacturing methods for high-temperature materials in collaboration with the Jet Propulsion Laboratory, who will also be represented in our faculty panel. Beyond his work in the lab, Zach is committed to strengthening communication and collaboration across Caltech's divisions and mentoring first-generation college students. Wes's research focuses on fundamental solidification of freeze-cast porous ceramic scaffolds for advanced filtration applications. I got that out. Outside of his research, Wes is dedicated to promoting sustainability initiatives across campus and to organizing events that foster a stronger sense of community among graduate students and the community at large. Let's welcome them both.
All right. Thank you, Kevin. I want to start with a brief anecdote. Earlier this year, as I was drafting a paper, I didn't realize it, but I was sort of overselling the results. When my advisor read it, she said, "Why don't we let the work speak for itself?" So we kept the data, we trimmed the claims, and the paper actually got stronger. She taught me something important about being a scientist in that moment, and that was to be excited, yes, but to be honest and to be a steward of the truth. Now, in case you didn't know, Caltech's motto is "The truth shall make you free." I have to admit that didn't mean much to me until recently. I'm a relative newcomer to science, and where I grew up, being a scientist felt about as achievable as being a movie star. I guess we're in the great place for both. That changed in my freshman algebra class when I applied myself for the first time and found myself loving math. It's crazy how that happens. I felt as if a wall had come down in my brain, and behind it there was just this empty room waiting to be filled with information. I've spent a few years now filling that room with information, with papers, experiments, all the raw material of a scientific life. But along the way, I realized that not everything deserves a place on the shelves. Mentors, professors, and peers showed me how to filter the signal from the noise and stock the inventory of my mind with what was reliable and true. And that's exactly why stewardship isn't solitary. If we want the future of science to be successful, we have to have discussions, we have to teach, mentor, and we have to talk openly about how discoveries really happen. Breakthroughs are not usually accidents. To paraphrase one of my favorite quotes from the polymer scientist Paul Flory, breakthroughs are usually the results of stocking the inventory of your mind so that when the spark of genius manifests, it has something to ignite. You're here now, and that means that you have a real part to play in making those breakthroughs happen. So during your first year at Caltech, I encourage you to stock up on that information. Build the library of your mind, and know that a community of peers is here to help you in the Graduate Student Council. Now, before you know it, you'll find yourself stepping into the role of mentor. And when you do, just remember that Caltech is what you make of it. So I encourage you to make it better for those that come after you. There's no better place for that than right here. Now, I won't wish any of you good luck because you don't need it. You've already proven yourself and you're here. But instead, I'll say, welcome to Caltech.
Thank you, Zach. As you just heard, Caltech is what you make of it, but one important thing I want to note is that you don't have to make it alone. When I first arrived here 2 years ago, I remember wondering if I truly belonged, as if I was at the bottom of a mountain that was impossible to climb, miles behind my peers. I quickly learned that almost everyone around me felt the same way, even if we didn't always say it out loud. Grad school is challenging, but it's not meant to be done in isolation. What makes Caltech so special is not just the groundbreaking science, but the people you'll meet along the way. The classmates who grind out problem sets with you late into the night, the new friends who share in your struggles and in your breakthroughs, and the limitless community that grows from those connections. Every one of you belongs here because of who you are and what you represent, not just the work you will surely accomplish. Each of you brings a unique perspective that this community needs, and over time, you will see how your presence here strengthens Caltech as much as Caltech strengthens you. So as you begin this journey, I encourage you to be generous with and kind to yourself, to support each other, and to take part in the life of this campus and Los Angeles outside of the lab. Celebrate the small wins, lean on your peers and friends, and strive to be the best version of yourself. And remember, your time here isn't about measuring up to your past. It's about leaving your own mark and helping shape what comes next. On behalf of the graduate student body, I'm thrilled to welcome you all to Caltech. We're so glad you're here. Thank you.
Thanks, Zach and Wes. So we now turn to the centerpiece of today's program, our faculty panel, which will foreground this year's theme, Advancing Intelligence, Science, Ethics, and Exploration in the Age of AI. Leading that discussion is my colleague, Dr. Frederick Eberhardt, Professor of Philosophy, Computing and Mathematical Sciences, and co-director of the Linde Center for Science, Society, and Policy. Dr. Eberhardt's work at the intersection of philosophy, data science, and policy makes him a uniquely informed guide through today's conversation about how responsibly we advance artificial intelligence. And I can say, if you will indulge a few personal thoughts, he was the first person that came to mind when I thought of this theme for this year. But, One of the great things about Caltech is we don't have departments, we have divisions. They're very interdisciplinary, so you're compelled at Caltech to interact with people that think about problems very differently than you might, and for whom problems themselves are very different from what you might imagine them to be. And Frederick has been very much that kind of colleague for me as an English professor. Joining him on the panel are three distinguished Caltech and JPL colleagues whose work exemplifies the breadth and depth of AI research at Caltech. Dr. Katie Bouman, Associate Professor of Computing and Mathematical Sciences, Electrical Engineering, and Astronomy, whose groundbreaking work in computational imaging, including contributions to the first image of a black hole, demonstrates how AI can help us understand phenomenon that were previously regarded as beyond our reach. Dr. Georgia Gkioxari, Assistant Professor of Computing and Mathematical Sciences and Electrical Engineering, and a Hertz Scholar, whose research in computer vision and machine learning is advancing how AI systems understand and interact with the visual world, with applications spanning robotics, healthcare, and beyond. And finally, Dr. Steve Chien, Senior Research Scientist at JPL, whose work deploying AI in space missions, from Mars rover to deep space exploration, shows us how intelligent systems can operate autonomously in the most challenging environments. Even as his work as a science advisor aligned these technologies with the public good. Please join me in welcoming our chair, Frederick Eberhardt.
Thank you all. Welcome to Caltech. I'm really excited to see you all here. I really hope that I get to meet a lot of you over the next several years through classes, workshops, conferences, coming by my office, say hello, cross paths with you on the campus. Would be great to meet many of you. Welcome. I'm excited to have you here. You are coming to one of the best places in the world to do scientific research. You will have the opportunity to really change foundational knowledge of what we have right now, of what we can do, of where we can go. And I ask you to push those limits, really go out there and see what you can do and make it better. Make sure that you try and get the best out of it, that you get the best out of it for all of us, and that you really see what can be done. Part of pushing the limits, I think, is sort of thinking ahead, asking yourself, where does that impact go that your insight provides? Can you think about where that impact can go in the right way to the right people? How does it change the world? What needs to change about the world so that you can actually have the impact in the way that it should play out? And can you somehow justify your insight and the impact that you want to have in a well-reasoned way so that we can all follow and understand and endorse it? I think that's something that you want to make a central part of your sort of work. It's one of the central missions of the Linde Center for Science, Society, and Policy that I lead, that we connect this sort of research that you do here on campus to the society at large, that we ask ourselves, what is the regulation that needs to change? What is the policy that we need to think about? What is it that we can do to connect you out to the world, and not just that your research gets published, that it goes with a nice press release with your face on it. We want that. Of course we want that. That's the first step. But the next step is to ask yourself, is that what's the change and how can we do it in the world? Okay, so of course that sort of engagement with society at large has to be a two-way street. We want to figure out, we want to learn what policies are needed, what society needs. Can we make the questions that society asks part of our research question in the first place, rather than as an addendum to our PhD thesis at the end? Can it sort of be a focus of our interest to solve the questions that society has at large? And then, of course, it's also the other way around, that we don't just want to do outreach work, but we want to see how we can make that sort of research relevant more broadly. At this intersection of society and science right now, one of the huge topics, as you're all aware, is AI, of course. And so we have to ask ourselves, how are we going to work with the AI that we have? How can we make use of it? And how can we sort of mitigate the negative consequences that might come that way? And so today on the panel, we have 3 extraordinary researchers here from Caltech who work in this sort of space and who I would like to discuss these, at least a few questions about how they use AI in their research, how they think about AI, what the effects are on education, and where we can push the sorts of boundaries going forward. Please join me in welcoming Katie Bouman, Gkioxari, and Steve Chien to the panel. Georgia, I want to start with you. You're a professor of computing and mathematical science here at Caltech and Hertz Scholar, and you work in developing advanced visual perception models. You take this sort of, your work takes sort of 2D images and then asks us like, okay, how do we generate 3D output from that? I've always thought that, one of the things I would love to send you is one of these Escher paintings where, the steps go down all the time in a circle, but they don't seem to actually descend. So I would wonder what the 3D output of that would look like. That would be great. But I take it that AI is like a central part of your work, and I would love to hear a little bit about where is the forefront of that sort of work, where is it going, and what is the latest development there for you?
Yeah, sounds good. So first of all, welcome everyone. It's great to have you, and I hope that you have 4 wonderful years here. So I work in computer vision. That means that I'm trying to build machines that see like you do. So right now you're looking at me. You've never seen me before, but you can understand what I'm saying. You can understand how I'm moving. You can understand everything. You also use your vision to come in here and sit in your seat. That is an aspect of intelligence that it's built in for you because humans are amazing. So how can we make machines be equally amazing? So this is what I research, which sounds daunting now that I describe it. But it's very fun. And of course, AI is a centerpiece because we do need to build artificial intelligence to make that happen. So your question is a good one, and I could maybe spend hours talking about it, but I'll try to summarize it in 3 minutes. So I find this to be the most exciting time in tech. I've been working with AI since 2010. You were 5 years old. So it's been a while, and AI looked kind of different back then, but the challenges were the same. And I have to say that right now, today, like this time, is the most excited I've ever been about the work that I do. And so we are at the cusp of this new discovery, new invention, which I dare say is as big as when the internet was invented. None of us were born. Some of us were not born then, but it was as big. I think that what AI is as big as the invention of internet. And so that is great, but there's a lot of challenges ahead. It's a new technology. And so I would say that there's 2 big directions that I believe are important, and I want to convey to you that are important. One is how can we use this technology that is quite new to accelerate scientific disciplines for the better of humanity. And I can't imagine of a better place to actually try to answer these questions here at Caltech, where you have this interdisciplinary, this connection of computer science, machine learning, AI with the sciences, and where you have faculty and students talk daily about these problems. And the second, more from a core AI perspective, is that because the technology is new, there's a lot of things that we don't understand. We don't understand exactly how it works. Well, we do, so hopefully you come to my class and you learn a bit more about that. But we really don't understand how the characteristics of it actually function. It's not robust, it's not reliable, that make it not a very good tool right now to use, but hopefully we'll improve that. And there is another very big challenge that keeps me up at night almost every day. which is the fact that it's really not efficient. In order to make AI work, we need a trillion parameters. Those are orders of magnitude more than the equivalent of parameters in your brain, neurons. And also, these systems need to learn from web-scale data. They need to absorb everything that is out there, all information that is out there in order to generalize. You need one example, sometimes 0 examples, to pick up a new skill. So this inefficiency makes it very, very limiting. And if we overcome that, I perceive a third big discovery and a new revolution in sciences. So these are kind of the topics. These are kind of what is at the forefront of AI technology right now. These are questions that we're trying to address in some of the research that I do, and also in the campus world, campus-wide.
Thank you, Georgia.
Was that too long?
No,
okay.
well, not long enough, I think.
Okay,
but
exactly. I have so many things to say.
We've got a few more years to talk. So,
Yes.
one of the fantastic things here at Caltech, I think, is it's small size. So it means, I always think of it like, if you look at the auditorium here, you're probably looking at something like 8 to 10% of the entire Caltech community and 25% roughly of the entire student body at Caltech. So it means that we can make connections very fast. We can make connections very well across many disciplines. We know each other fairly well. We know what's going on in other parts of campus or can find out very quickly. Make use of that. I have benefited enormously from doing so and making connections across campus. It's been fantastic. And then in addition, we have the Jet Propulsion Laboratory just down the road, where all the sort of space science and climate science is done as well. And Steve Chien here is one of the technical fellows in artificial intelligence at JPL and has worked on several missions, including the ESA Rosetta mission and the Mars Perseverance rover, and also on the policy side has worked as advisor to several government agencies, which is of course a particularly interesting aspect for me as well. So Steve, welcome to the panel, and tell us a little bit about what the role of AI in space science is right now. AI, I'm thinking, so alien intelligence is what exactly I've been waiting for a while.
So we'll start with the easier part of that. So where are we today in AI? So I'm very pleased to be standing here and saying to you that there are not 1, but 4 different AIs on the Perseverance rover at Mars that allow it to drive further on its own, that allow it to select science targets on its own with inputs from scientists, but it's autonomously selecting the targets, and to better manage its resources. Say if it wakes up and the battery state of charge is different from what we expected, even with all the engineers, much like when you look at your phone and, oh my God, it's suddenly about dead, or your battery on your computer is unexpectedly a different state of charge. And so the rover can actually make all of these decisions on its own in order to be more efficient. And previously it was mentioned that Chiava Falls rock in the Emerald Hills sample, which is discovered the closest thing to an astrobiology signature that we have, that was discovered under the onboard planner control. So the rover was under the control of an AI system when it was doing that sample, when it was doing all of the relevant context science for 7 or 9 sols around that. So that's an example of how AI is being used today to advance science. How will it be used in the future? I'm very passionate about the best way that we will discover life beyond Earth is with an AI-powered robot. There are mission concepts to Europa, the Europa lander, and the EELS robot to the Saturnian system, Enceladus, which astrobiologists tell me are the most likely places where we will find life beyond Earth in this solar system. And those missions require artificial intelligence. In the past, we've used AI to enable the missions to operate more efficiently. In these other cases, the environments are so hostile, the AI will have to make judgment decisions. It will have to use what we call decision theoretic planning. It has to balance likelihood, risk, and reward in order to make the best decisions, because on Europa lander, the lander would land and it only will last about 30 days. In about half that time, it can't talk to the Earth. So it has to be making decisions on its own out of every 3.5-day orbit. Half the time it's on its own, and it's sampling like mad, analyzing like mad, and deciding what to do. So that's my answer on the astrobiology question.
I think you got both, yes. Thank you. Katie Bouman, obviously famous for your work on the first picture of the black hole. You make nothing visible. I mean, you make where nothing is visible, so rather than making everything invisible. That might be easier. So the signal processing that you do in your work has to be extraordinary. I take it that AI now plays a huge role in that as well. Can you say a little bit about that? And, you know, in sort of facing the challenges of AI, I'm also particularly curious is that how do you make sure, especially in work like yours, in astrophysical work, like that your answers are going to be correct or that you're confident in the results of your answers that you get from AI?
Yeah, good question. So maybe I'll just start with saying a little bit about what my work is about before we say where AI plays a role. So yeah, a lot of my work is about how do we add computation into the imaging system. So for centuries, we've kind of taken pictures that are modeled just based upon the human eye. You know, you have light, goes through a lens, makes a picture, but that really has limits of what you're able to see. And so how do we push those limits? How do we push the boundaries of what we're able to see things that are currently invisible under traditional kind of imaging sensors? Well, the way that my group has been doing it is by adding computation into that mix. So by taking something that you think of as non-ideal measurements, they don't look like a picture necessarily initially, but then you use algorithms to interpret those measurements as a picture. So one way that you've probably seen this in your everyday lives is like if you've gone in to the doctor and the doctor says, oh, we have to take a scan of your body, an MRI or a CT scan. They're not like cutting you open and taking a picture. They're using some sort of measurements that we understand how those measurements have been affected by the internal, the tissues of your body and everything, and then we use algorithms to try to convert those into a picture. But the challenge is when you're doing this is that the data is not usually, it doesn't usually give all the information you need to make a picture. So it'll be noisy, or in a lot of cases, there's just a lot of missing information. So for instance, if you were to go in to get that MRI scan and you were just in there for all the time that it took to take every single measurement to make a picture, it would be a really long time and they wouldn't get to see as many patients or deal with, for instance, pediatric patients or people who can't stay in the scanner as long. So we have to come up with ways that we kind of fill in those gaps of knowledge that we create for ourselves. And one way we do that is through AI. So actually, before I get to that, I'll just say, talk about the black hole and problem, because I think that also helps to explain it. So I was part of this team that took the first image of a black hole, and the whole challenge with taking an image of a black hole is because it's so far away and so compact, we would have needed a telescope the size of the Earth. Couldn't do that, so we instead had telescopes distributed around the world, and each telescope only takes a little small fragment of the information. So again, it's this problem of we have a ton of missing information, but we want to make a picture that we really believe and that is actually out there. We don't want to make up information. So in initial pictures that we created, we used very simple kind of constraints on the image. Things like, let's make the image we want it to be a smooth image. You don't want it to look like noise, like on a TV static or anything. But once we get a picture and we start to believe, this is kind of looking like how I expect a black hole to look like, well then can we use AI to pull out more information from that? Again, we have those holes of information, so we want to be really careful about that, but can we use AI to try to say, well, assume it was under it obeyed Einstein's theory of general relativity, then what could we say more about the black hole in that case? And so that's kind of what we're currently using AI for. We can take large data sets of different types of images and use, for instance, ideas from generative from image generation methods, and that you've probably generated images from using things like DALL-E. And we can incorporate that into the imaging methods to say, well, what does the image look like if we had assumed it had the statistics of these types of images? And that might be pretty scary at first because you're saying, oh, we're like hallucinating a bunch of information. But actually it allows us to be more robust and understand our biases more, because rather than just having hand-designed kind of mathematical expressions that allow us to say, well, what is the kind of image I prefer? Now we can easily plug in lots of different types of images. Let's say that what if the image of the black hole looked like a cat, or looked like a dog, or looked like a human face, or a model of our black holes? How does that change what the image we get out at the end? And obviously, we don't think that the image in the center of our galaxy looks like our face, but actually we find that when we do things like this, it tries to make a face that looks like the black hole image, right? So in doing that, we can kind of pull out what are robust features and what are features that we don't believe that are just there because our AI method is hallucinating information. So actually, we're kind of using hallucination to our advantage to understand what is a robust feature and what's not.
Oh, thank you. About 5 years ago, just before ChatGPT exploded on the sort of broader scene, I decided to add the course in ethics and AI to the curriculum here for undergrads. That was a big mistake because the field is moving so fast, so that course needs to be revised all the time. So at the time, the big topic was algorithmic fairness, which now feels a little bit like studying Aristotle. Still super important, but you know, the music has moved on to playing elsewhere. But I think these sorts of topics are incredibly important to sort of integrate into our understanding and our education. And so, Steve, I'm actually particularly curious about where sort of ethical questions with regard to the use of AI crop up in your work at JPL, and like, are there guidelines for AI use at JPL, or how does that work?
Well, I would reinforce what you said. It's a very rapidly evolving playing field. I'm going to answer your question in the same way that I answered it when I was talking with some members of Congress. So really, ethics and fairness in AI is really a question of bias and understanding the bias of different algorithms. And AI is just a particularly advanced algorithm that we have not characterized as well as other algorithms that we've used. But we should be, as scientists, obsessed with the bias in these algorithms. Let me give you an example. We have a targeting system on the Perseverance rover that helps select science targets for the SuperCam laser. There's an inherent bias in that target selection algorithm. We know that it will pull out targets with a high albedo more effectively because the computer vision techniques that it's based on will do that. So if we actually make some statements about the measurements from those science campaigns, we have to understand that we have a biased sample already to start with. And then there are standard ways of, well, I should never say standard. There are ways of counteracting that bias, and we have to ensure that everybody understands those sources of bias, the ways of measuring that bias, in order to conduct proper science.
Great, thank you. Katie and Georgia, you both teach graduate and undergraduate courses here at Caltech. You know, when I get an AI-generated paper, I return an AI-generated grade. I think of it as sort of a win-win situation. So, but I guess more seriously is I would like to hear from you a little bit apart from the sort of concern of that. Is the code that is submitted in your classes LLM generated? Do the students know that what they actually submitted in their paper, or was it just AI generated? I'm curious to hear from you both about what you think of as the role or threat to AI, from AI in education here. Does either of you want to start?
I guess, sure.
Katie, go ahead.
Yeah, I mean, it's a really good question, and honestly, one that I'm still grappling with. I don't know the answer. I would say that, like, my current thinking, though, is it really kind of depends on the class and the kind of material that you're learning. So one argument you might have is, like, I think back on my elementary school, and, like, I had to, at that time, I don't know if they still do that, but I had spelling tests. And I think anybody who knows me now would guess I was absolutely horrendous at spelling tests. And right now, I rely heavily on spell check. So were those spelling tests useful? Well, in some ways, no, I'm still really bad at spelling, but I've been able to still, like, do something with my in my work. But at the other sense, like, yeah, if I hadn't had them, probably people would think I'm just illiterate and wouldn't get anywhere. So like there is like some sort of balance there. But what is like most similar to spelling tests here at Caltech? Well, maybe things like memorizing equations. And I think for the most part, like most equations, you don't have to just have memorized, and it's okay that you like go and look it up in a textbook or now ChatGPT or whatever, and then double check it in that case. But some are important to have at your fingertips, like F equals MA, and they just build understanding of and allow you to kind of move, and come up with new ideas more quickly and have a deeper understanding of what you're doing. So, but I don't think what you're doing here is not memorizing equations. It's trying to learn material that actually it's not just learning material, it's learning how to learn. Most of the material I learned in, I think, undergrad, I've probably forgotten, but I have it enough. It's like riding a bike where you can go back and you can learn it more effectively or learn new material more effectively. And I think using AI for that as a shortcut to learning how to learn can be really detrimental. So I think you have to be really careful with that in those kind of situations. On things like when you're trying to come up with new novel, when you're doing kind of research-related work and maybe project-level class, you really want to, though, be at the cutting edge of what you're doing. And there, yeah, I think it is really helpful to use AI to supplement and help guide you in your work. But again, you have to be really careful, because if you fall into the pitfall of just letting it do a lot, you lose an understanding of the work that you're doing, and you can't effectively build on it and understand it enough to move forward. So I think it's a balance, and it kind of depends how much to balance it based upon the material that you're trying to learn.
Georgia, do you want to?
Yeah, I mean, I have a lot of things to say, and I'm trying to figure out what to say that's going to hit well. So AI is here, and telling you that you're not going to use AI is like telling you to not use the calculator, which is stupid. Of course, we are going to use the technology to help us. But you're now at the time of your life, and you are at an institute whose mission is to actually push the boundaries of science and technology. AI is very good at the things that it has seen many, many, many times. Those things that it has seen many, many, many times are not going to push the boundaries of technology, because we don't know what the boundaries are, and we don't know where we're going. This is where human intelligence is critical, and this is what we want you to acquire here. So you're here to learn. You have the tools and the means at your disposal to help you learn, but you should not be replacing them. So this is what I tell my grad students that we do research with. And actually, if you ever talk to them or find them on campus and ask them, could you do the research that you do could AI actually do it? Absolutely not. We actually do this experiment every time. We just got out of a paper, like a ML conference that we had a few days ago, 2 days ago. We submitted a bunch of papers, and then we actually run this experiment to see, could AI have done the paper, not just the writing. The writing, absolutely, we use it all the time to give us fancy words, but could it have done the scientific innovations, written the code that we needed to design our experiments? And the answer to that question is absolutely no, because it's outside of its training domain. So if you have things that the model has not seen, which hopefully this is what you will be doing here at Caltech, AI is not going to help you. So the goal of your education is to acquire the critical thinking and the skill set to actually design experiments. And that includes software skills if you're in computer science. AI coding assistants are really good. They'll give you great code for the things that it has seen, like least squares optimization. I know how to do this in my sleep. It is going to be very good at that, but it's not going to be very good at doing the things that it hasn't seen, which is what we ask out of our researchers to do here. So I really think that if you want to be at the forefront of tech, if you want to be the next innovator, the next Nobel Prize winner, or the next Turing Award winner, which is what you should be aiming for, by the way, then AI is not going to help you. You need to train your brain, and that comes through the rigorous education material here at Caltech.
Thank you. And I think you will find that this sort of discussion about AI and the use of AI, both in research and in education, is very alive here on campus. You would think that with the density of Nobel Prize winners here, we would have solved it already and knew exactly what to do. But that's not quite the case, unfortunately. We're working on it. But the discussion is really broad. I've been involved with many discussions with students, with faculty, with the administration about how we work and figure out what to do with AI and where it can go, how it helps, where it's detrimental, where does it advance learning, where does it hinder learning. And I hope that you will also sort of seek out the opportunities to engage in that discussion, because this is an unsolved problem and we need to sort of figure out in finding the right balance, just as you said. Now, I want to pivot away slightly from the AI discussion to the sort of convocation event. And I have to admit that it's been a while since I started undergrad and grad school. And to be honest, I don't remember a thing about the first day at either of those institutions. And I guess, in some sense, I hope that you will take away so many more exciting experiences from Caltech that convocation will not be the crucial memory that you have here either anymore. But having said that, I think I would be curious to hear from our panelists about what you would say to your former self at the point of convocation in either undergrad or grad or both, what advice you have to your former self, or maybe to students here starting at Caltech, because maybe Caltech is a very different institution than where you went. Steve, do you want to start?
Yeah, I guess the number one thing I would say to all of you is don't say no to yourself. There's so many things out there in the world and very many experiences to have. I myself, I've been in a little bit in the academic world. I've worked with flight projects. I've had 3 startup companies. I've worked with the US government. I think the amazing thing is the world has all these different paths to follow, and listen to yourself and follow the ones that call out to you, but don't say no to yourself. There's so many things that that people will say, well, you can't do that at such and such age, or you can't do that, you haven't had this degree. I don't really believe that the world is like that anymore, and I would say, go for it, go try, and be fearless.
Katie.
Yeah, I mean, I agree with a lot of what he said, but I would say that, yeah, I think one piece of advice I have is just, always think you know where you're going, but be willing to change that direction. So I think that why do I feel that? Well, I feel like a lot of times people go in to, especially grad school or undergrad, and you're trying to decide what degree to get. And you're like, I don't know, and I'm undecided. But I think then a lot of times people just do this random walk and don't move anywhere in those cases. Whereas if you think, oh, I think I want to do this thing, it's okay if that's wrong, but you're kind of moving in the forward direction and you're making some sort of progress. So I think but also being willing to change. So for me, when I started grad school, I was very convinced I wanted to do, well, I did a PhD in a computer vision field, but I wanted to do very mainstream kind of computer vision. Face recognition at that time was, like object detection, this kind of stuff. And so I came in and I was told my advisor, oh, I want to do this. And he was like, maybe you should try something else. And I remember being upset that he wasn't letting me. I was like, I came in with a fellowship. I should be able to do whatever I want. It wasn't, he was kind of giving me advice on directions that might be more interesting for me to pursue at the time with my kind of skill set. But I remember thinking, okay, well, I just want to do this. I'm just going to move forward. But over time, I realized, you know what, that's not actually what I want to do. And I found other directions, eventually working on this black hole imaging project that really drew me in. And of course, when I started, there was no way, I had no idea that I wanted to do that, anything along those lines. But I think that I was glad that I think it was really good that I kept making progress on something and then allowed myself to pivot. And I'm still doing that to this day. The first day I started here at Caltech as faculty, I met Zach Ross, who's in the seismology department here, and I was like, hey, we started talking, we were like, we should work together on this project. And I've pivoted again to a different area that I had never worked in before. So I think that I think it's just moving forward, making progress, but allowing yourself to move around.
Georgia, do you have a few thoughts? I'm also maybe anything for people coming in from abroad who have a somewhat
I was
different...
actually going to say that. So these are all great. So I want to just add on to the great piece of advice that you've heard so far. So maybe to add, maybe this is for the international students out there. So I did my undergrad in Greece, very close to home. I actually lived with my parents. I know, lame. But when I went to grad school, I went from Greece, I don't know if you know where it is, like kind of very far in Europe, the most beautiful country, but like kind of, to the east. And so I took 2 suitcases and came over to California, to Berkeley. I was the first time in my family I came alone. My parents don't speak English. They wouldn't really be of any help. So I found myself in a completely new environment, away from home, away from my friends, new people, new culture. The culture shock was actually huge. Like what was happening was the food was like not great. Go to Greece, it's amazing. So I found that one thing that really helped me, this is the thing that I really is maybe my most important. Something I'm very proud of is that I really built a home. I found the people that I love to be around, and that took a while, like not everybody you meet is going to be your friend, but building that system of support. But at the time, I didn't know it was a system of support. They were my friends, and I was having a really good time. But you're going to be here for years, like 40 years of your life, and at any given moment in your life, when you are looking at a 4-year span, you're going to have high and lows. So you want to have the system to actually go through those high and lows. So you're going to have to receive support, but also offer support to your peers. And I found that to build that environment to be very crucial for anything, from happiness to success in the academic world. So that would be my piece of advice: build your home.
Yeah, thank you. I agree with all of those. And I guess I will only add to that is that, remember, Caltech is a spectacular institution, but it's also situated in a spectacular part of the world. Go explore Los Angeles, go explore Southern California. There are extraordinary people outside of Caltech as well to hang out with, to find out what they're up to explore the food, the music, the shows, to the ocean, the desert, the mountains. They're all within an hour of here easily. Make use of that. I know you come here to do research, to do exciting science. I think, or at least my experience is that in a significant way, exploring that sort of environment around you and having that sort of balance there helps doing that sort of extraordinary science. And here you're in an environment where it's close by to do something else as well. So welcome to Caltech, and please join me in thanking Katie, Georgia, and Steve. Thank you. So you head back down.
Thank you. And just to, if you're feeling dazzled, excited, a little daunted perhaps, welcome to Caltech. That's what you will be experiencing. And I do want to just reinforce what Frederick said about the part of the world you've entered. Undergraduates in particular, one of the striking things to me is that when you visit here as prospective students, one of the things I consistently hear is how small our campus is compared to other campuses. And within a few months, you'll complain if your morning class is at the other end of campus. So that's okay at 8 o'clock in the morning when you're not keen to go outside. But at other times in your life, please do explore what awaits you. And with that in mind, at this point, we would like to share a video that's been produced by our technical team and that captures some of the energy and diversity and spirit of the Caltech community and what lies ahead for you.
This is where curiosity leads to world-changing discovery. This is inventing the tools and technologies of the future and using them to expand knowledge, improve lives, protect the planet, and open new frontiers of science and innovation. This is unprecedented understanding of the human brain, from a single nerve cell to a sea of emotion. This is pushing the limits of possibility to investigate the building blocks of nature and to navigate the unknown. This is a legacy of exploring the far reaches of the solar system and opening new vistas on the universe. This is where tomorrow's trailblazers work alongside scientists and engineers who have defined their fields, and where every day creative thinkers come together to ask questions, to tackle problems, and to be inspired. This is Caltech.
All right. So before we conclude entirely, I do want to express my appreciation to everyone who is involved in pulling this event together. I particularly want to thank community members who joined us to welcome our students. And a special thank you to the behind-the-scenes team who delivered this year's convocation. And I can't see from on stage, but I do know these people, and if they're here, thank you. Gordon Alamo from the Student Affairs Administration Office, Shayna Chabner-McKinney and Nate Stuffel from Campus Events, Leslie Maxfield and her team from Academic and Media Technologies, Isabel Peng from the Office of Student and Family Engagement, who's been singularly leading the entire orientation process this week, and Francis Yokota from Dining Services. Join me in thanking them. So it's time for brunch now, and you're all invited. Now, as we move to our community brunch on the Beckman lawn, I invite everyone to join us for lunch, but I invite only the students to leave first, guided by the deans. And the rest of you, do please wait until our students have left. And let's close as they leave with one final round of applause.